Hello, today we are going to be going through your Chapter 1 practice test. So the first question here says, what is the constant rate of change of the table? So remember guys, when we're talking about the constant rate of change, we are pretty much just finding the slope of the table. And if you guys recall, to find the slope of the table, we are looking for the change in y's over the change in x's. Okay, so our seconds here, time is always going to be our x because we can control time, and then our meters, it depends on the time, so it's going to be our y. So in our fraction, the change in y's over the change in x's, we are looking for the changes that happen when we jump from one number to another. So let's see what happens. So here we go from 40 to 80, so that means that we went up 40, so we increased 40. Here we went from 80 to 120, so again that was another plus 40. And then from 120 to 160, again that was another plus 40. So our change in y's is that plus 40. So our numerator is going to be 40. And then looking at your change in x's, notice how we went from 10 to 20, so that was plus 10. 20 to 30 was plus 10. And 30 to 40 was also plus 10. So our change in x's were the tens. So our rate of change is 40 over 10. But you must reduce if you can, and in this case we can reduce because we can divide both of these numbers by 10. And as you guys can see, we are going to get a unit rate of 4 over 1. So this means that for every second, our meter jumped 4 meters. So our answer here is B, 4 meters per second. All right, number 2, what is the slope of the line? So again, to find slope of a graph, we are using our formula rise over run. And you need 2 points on the line to find the slope. So let's say I pick this point and this point. And out of those 2 points, you start with the one furthest to the left, and you're trying to get from point A to point B. So you have to be careful when you are rising, because remember, we're always going to rise first and then run, because in our fraction it's rise over run. When you're rising, don't always count by ones, because you need to come over here to see what you're really counting by. So if you notice, we're actually counting by fives. So every time you go up 1, you are really going up 5. So I'm going to count by fives here. So we're going to go up 5, 10, 15. So we rose 15 to get to our second point. And then when you run, notice how we're going by 0.5. So when you're going to count over, you're going to count over by 0.5. So this will be 0.51. So we rose 15 and we ran 1. So that means that our slope is 15 over 1, which means that our answer here is F. All right, number 3, Selena babysits on the weekends. The equation y equals 12x represents the amount of money she earns. What is the constant of proportionality? So remember guys, when we talked about direct variation and constant of proportionality, it is in the format of y equals kx, where k is your constant of proportionality. So looking at the equation y equals 12x, notice how the constant of proportionality is always attached to the x. So what's our constant of proportionality? The number that's attached to x is 12, so her slope is 12. So that means that she makes $12 an hour babysitting. All right, number 4, what is the solution of this proportion? So remember, when we are solving a proportion, we are cross multiplying. So in this case, I'm going to take 11 times r, which is 11r. 22 times 13, so I have my calculator here. That gives me 286. And then our last step to get r by itself is to divide by that 11 on both sides. So 286 divided by 11 gives me 26. So our answer here is F. All right, and then number 5, which size can of soup shown in the table has the lowest unit price? So remember, guys, when we're talking about unit rates, we need our denominator to be 1. And when we are trying to find the unit rate, our operation here is division. And we just have to make sure that we are always dividing our y divided by x. So in this case, our cost is going to be the y, and our size is going to be the x, because we can control the size and our cost depends on the ounce. So that's why we are going to take the cost divided by the ounce. So to do this problem, like I said, you're going to take your cost divided by your ounce, and you're going to do this 4 times. And we are going to see which ounce has the cheapest unit rate. So our first one here is the 79 cents divided by 10. So if I take 79 cents divided by 10, this gives me 0.079. Our next one was $1.29 divided by 15. That gave us 0.086. Next one was this 2.16 divided by 18. Which gave us 0.12. And our last one is this $3.19 divided by 32. And that gave us 0.099 and so on, and I'm just going to leave it like that, okay? So based on our answers, which one had the cheapest unit rate? So which one was the cheapest? And if you guys are having a hard time realizing which one's the cheapest, you can always line these up going vertically. And figure out which one's the cheapest. So look at the tens place. So I see a 0, 0, 1, and 0. So since zeros are less than 1, I know it's not going to be this one. Then look at your hundreds place. We have a 7, 8, and 9. So the smallest number here is the 7. So that means that this 0.079 is our cheapest price. So that one was talking about the 10-ounce can. So our answer here is A. All right, number 6, this is a conversion. And we didn't really talk much about this in class, so I will tell you guys that this is not on your test, but I still just want to talk about it just in case it does pop up on iLearn. So let's go ahead and review this. So it says a fox can run at a speed of 42 miles per hour. How many feet per hour is this, okay? So your conversion factor is there's 1 mile and 5,280 feet. So if we're trying to change miles to feet, I'm going to write this as a fraction. And if I'm trying to change miles to feet, I need to make sure that I cross-cancel miles out. So since miles is in my numerator, I'm going to put miles down here in my denominator so that they will cancel each other out. Which means that if I'm trying to convert this to feet, I'm going to put feet in my numerator. So now all that I have to do is move these numbers over here in my fraction. So since we had feet on top, feet was talking about the 5,280. And since miles was on bottom, the 1 is going to be on bottom. And then we're just going to multiply across. So first thing we're doing is taking 42 times 5,280, and that gives us 221,760. And then multiply your denominators. 1 times 1 is 1. So our answer here is 221,760 feet per hour. So that is answer A. All right, number 7, the graph shows the amount of money Joe earns each hour he works. Which statement or statements about the graph is or are true? So there might be more than one correct answer here. So the first one says the graph shows a proportional relationship. So remember, in order for a graph to be proportional, it must go through the origin and it must be a straight line. So let's see if our graph has both of those. So number 1, does it go through the origin at 0, 0? It sure does. Requirement number 2, is it a straight line? It sure is. So it is a proportional graph. So we need to keep going to see if there's any other true statements. So G, the graph shows a non-proportional relationship. Well, we just said that it was proportional, which means that it's not going to be non-proportional. They can't be the same thing at the same time, so it's not G. Letter H, the unit rate is $15 per hour. So unit rate is when you have 1 hour. So I'm going to go to my x-axis and go to 1 hour. And then see if it is at $15. So I do see a point here, and notice that it is at $15. So that is our unit rate. So it is H. And then the last one here, I, the line is straight. Well, we already said that it was straight because it was proportional. So that means that that is also our answer. Okay, moving on to number 8. The table shows the cost for ordering a certain number of pieces of chicken. What is the value of X if the cost is proportional to the number of chicken pieces ordered? So there's a couple different ways that we can do this, okay? One way is we can find the unit rate. So remember, when we're finding the unit rate, you're just taking your Y divided by X to see how much one piece of chicken costs. And then we could take that number and multiply it by 6 to figure out our X value here. So let's just go ahead and try that. So let's figure out how much one piece of chicken is. So I'm going to take the cost, so $3, and divide it by the number of pieces here. So there's 2. So if I take 3 divided by 2, that tells me that each piece of chicken costs $1.50. So if one piece of chicken costs $1.50, and I'm trying to figure out how much 6 pieces of chicken costs, I can just take this $1.50 times 6, and I'm going to get $9. So my answer here is $9. Okay. Another way you can do this is you can find the slope. So as you can see, our numbers are going up by 150 every time, but you have to be careful because notice in our table how they skipped 5. So when you add 150 to 6, that gives you 750. But notice how that was not our answer because 750 is talking about 5 pieces of chicken. So you would have to take 750 and add another 150 to figure out what 6 is. So my advice is to do it this way by finding the unit rate, so finding out how much one piece of chicken costs, and then multiply it by how many chicken pieces you want to see how much the price of that is. Okay. All right, moving on to number 9. If it takes 4 gallons of gas to drive 92 miles, how many miles can be driven using 6 gallons of gas? So guys, it tells you to write a proportion, but another indicator here is knowing that as soon as you see 3 numbers and you're trying to find a missing number, this is when you need to set up that proportion, okay? So remember, when you guys are setting up proportions, everything has to be aligned. So I like to write down my units that we're talking about here. So my units that I see are gallons and miles. So when I go to set up my proportion, I need to make sure that these 2 numbers up here in my numerator are talking about gallons, and I need to make sure that these numbers down here in my denominator are talking about miles. So looking at the first piece of information that they give us, they say that if it takes 4 gallons of gas to drive 92 miles, then I'm going to set that up as a fraction. So 4 gallons was talking about gallons. I have gallons in my numerator, so I'm going to put the 4 in the numerator. And then 92 is talking about miles. Since I have miles in the denominator, I'm going to put the 92 in the denominator. Okay. Then look at what we're trying to find. So we're trying to figure out how many miles can be driven using 6 gallons of gas. So since the 6 was talking about gallons, again, I have gallons in the numerator, so the 6 is going to go up here. And then I'm trying to figure out how many miles, so my variable will go down in the denominator. Okay, so now let's just go ahead and solve this. So again, when you're solving a proportion, you're cross multiplying. So 4 times x is 4x. 92 times 6 is 552. To get x by itself, you are going to divide by 4 on both sides. So 552 divided by 4 is 138. And notice how this is a word problem, so I do need a unit here. X was in the denominator and x was talking about miles, so my answer here is 138 miles. And it does say how many miles are we looking for, so that's another indicator that we are talking about miles. Alright, so let's try another one. Martin can travel 174 miles in 3 hours. At this rate, how far can he travel in 7 hours? Okay, so again, first thing I like to do is look at my 2 variables that I'm talking about and write those down as a fraction so that I can keep everything aligned in my proportion. And then we can go ahead and start looking at our first piece of information. So they said that Martin can travel 174 miles in 3 hours. So the 174 was talking about miles. I have miles in my numerator, so I'm going to put 174 up there. 3 hours, 3 was talking about hours. Hours is in my denominator, so I'm going to put the 3 in the denominator. Then look at your other piece of information. So we're trying to figure out how far can he travel in 7 hours. So the 7 was talking about hours. I put 7 in the denominator, and I'm trying to figure out how many miles can he go. So once you set up your proportion, go ahead and cross multiply. So 3 times x is 3x. 174 times 7 is 1,218. And then to get x by itself, you're just going to divide by 3 on both sides. So 1,218 divided by 3 gives us 406 miles. Alright, last one here. Bart can type 296 words in 8 minutes. At this rate, how many words can he type in 20 minutes? So again, first thing I'm doing is I'm looking for my units, and we're talking about words and minutes. And I'm going to use this to help me set up my proportion. So first thing I see here is 296 words in 8 minutes. So this will be 296 on top since it was talking about words, and 8 on bottom since it was talking about minutes. Then at this rate, how many words can he type in 20 minutes? So I see 20 was talking about minutes. Minutes is in my denominator, so I'm going to put the 20 over here in my denominator. And then I'm trying to figure out how many words can he type in that 20 minutes. So cross multiply. 8 times x is 8x. 296 times 20 is 5,920. And then last step to get x by itself is to divide by 8 on both sides. So 5,920 divided by 8 gives us 740 words. So in 20 minutes, he can type 740 words. As always, you can pause the video, but I'm going to go ahead and move on to the next one. Number 12, which size bag of cat food shown in the table has the lowest unit price? So this is very similar to that last question on the front page that we did, where to find the unit price, remember we need our denominator to be 1, so our operation that we're doing here is dividing. And you're always taking your cost divided by our ounce here. So again, to find my unit price, I'm going to be setting up ratios for each of these ounces with their cost, and then divide them to figure out which one has the lowest unit price. So the first one here, I'm going to take the 549 divided by 24. And that gives me 0.22875. So I'm just going to write 0.229 because I'm going to round it. The next one is 8 divided by 40. $8 divided by 40. And that gives me 0.2. And then the last one is the $15.99 divided by 64. And that gives me 0.24, we'll just say 0.25. Okay? So looking at our unit prices here, we have 0.229, and we can round this to 0.23 if we really wanted to. So we have 0.23, 0.2, and 0.25, so which one's the cheapest? Well, this is 23 cents. This is 20 cents because I can put a 0 here. And this is 25 cents. So the cheapest one here is the 40-ounce thing of cat food for $8. Because 20 cents is less than 23 cents and less than 25 cents. Alright, so 13. The graph shows the savings of Mia and Kyle. What is the slope of each line and what does the slope represent? So, let's find the slope of Kyle first. So here's Kyle's line. So again, to find the slope, you just need 2 points on that line. And we are going to use the formula rise over run to figure out what our slope is. So starting with the point furthest to the left, again, don't assume that you're counting by ones. You actually need to come over here to your y-axis to see what you're counting by. So notice how I'm going from 20 to 40. So in other words, we are counting each line by tens. So when I go from 20 to 40, I'm rising 20. And you can also count 10, 20. So I went up 2, so I went up 20. And then notice how we are going from 1 to 2 here. So 1 to 2 means that I'm adding 1. So my slope then, rise over run, would be 20 over 1. Or in other words, just 20. Okay, so let's do the same thing with Mia's line. So again, choose any 2 points. So let's say I choose these two. Actually, I need 2 points that cross that intersection, so I have to choose 0, 0 in this point. Okay, so these are the only 2 points that I can choose. So again, starting with the point furthest to the left, we are trying to rise to see how far we can get to this point, and then we're going to see how far we run. So looking at my y-axis, I'm starting here at 0, and notice how when I'm rising, I'm stopping here at 30. So when I went from 0 to 30, I rose 30. And then I'm running all the way over here. So I start at 0 and I ended up at 2. So that means that I ran 2. So if I rose 30 and ran 2, that means that my slope is 30 over 2. And I do need to reduce that because 2 goes into both 30 and 2. So 30 divided by 2 here gives me 15. Alright, so what does the slope mean? Well, looking at my slope here in my table, we're talking about monthly savings. So my x-axis is talking about months, and my y-axis is talking about money. So my slope would represent the amount of money saved each month. Okay, so when you guys are writing your sentence, make sure that you include your x variable and your y variable in your sentence, and make sure that it is talking about what the graph is talking about. All right, number 14. A grocery store sells 6 bottles of water for $4 and 18 bottles of water for $10. Is the cost of the water proportional to the number sold, and explain? So there's a couple different ways that we can do this, and I'll show you guys both ways, okay? One way is if we're trying to figure out if it's proportional or not, we know that we must have same unit rates, so we must have equivalent ratios, okay? So one thing that I can do is I can look at my two set of numbers here that I have, and I can find the unit rate of each one. So again, if we're talking about cost and the amount of something, the cost depends on the amount, so I'm going to take that $4 divided by 6, and then find the unit rate by dividing. So if I were to take 4 divided by 6, that gives me 0.6 repeating over 1. And then we're going to do the same thing with the $10 over 18 to see if it's proportional again or not. So if I were to take 10 divided by 18, that gives me 0.5 repeating over 1. So were these the same ratios? Were these equivalent? They were not. So these are not going to be proportional. So down here you can say they are not proportional because we did not get equivalent ratios when finding the unit rates. And that would be a perfect sentence, okay? Another way that you can do it is if you're talking about proportionality, if you were to set up a proportion, so the 6 bottles of water for $4 and 18 bottles of water for $10, if you were to cross multiply, your cross multiplication have to equal each other. So like if I were to take 6 times 10, that gives me 60. And then if I were to take 18 times 4, that gives me 72. So does 60 equal 72? It does not. So that is another way that you guys can tell if these are proportional or not. All right, 15 and 16, we're just solving a proportion. So like I said, when we're solving proportions, we're cross multiplying. So if I were to take 0.5 times k, that gives me 0.5k. Then if I were to take 13 times 0.6, that gives me 7.8. And then our last step here to get k by itself is to divide by that 0.5. So 7.8 divided by 0.5 gives me an answer of 15.6. All right, number 16, so again, cross multiply, so 3 times v is 3v. 6.5 times 11.7 is 76.05. And then last step to get the v by itself is to divide by 3. So 76.05 divided by 3 gives me 25.35. All right, number 17. So again, this is another conversion problem, so this is not going to be on your guys' test, but again, let's just go ahead and review it. So when diving, a hummingbird can reach a speed of 40 miles per hour. What is the speed in miles per minute? Use a conversion factor. So here we are trying to change hours to minutes. So if I'm trying to change hours to minutes, I want to make sure that I can cross cancel hours out. And when I cross cancel, oh, sorry, I just realized I did something. So I always want to start here. So this says 40 miles per hour, so I'm going to write that as a fraction, 40 miles per hour. And now here, since I'm trying to cross cancel hours out to get to minutes, since hours was in my denominator, I'm going to put hours up here in my numerator so that now these can cancel out. Okay. So that was my fault. I should have started with the number that we had first. There we go. Okay. So So now that I have hours canceled out, I need my conversion. So if we're trying to go from hours to minutes, I know that there are 60 minutes in an hour. So I'm going to set this up as a fraction over here. So hours was on top, 1 was talking about hours, and if I'm trying to change this to minutes, 60 was talking about minutes, so that's in my denominator. And then now I can just multiply across. So 40 times 1 is 40. 1 times 60 is 60. And then if I were to reduce this, I can divide by 10 here. So that gives me 4 over 6, but then I can still divide by 2. So then that would give me 2/3. So this means that there's going to be 2 miles per 3 minutes. Alrighty, and the back page. So does the graph show a proportional relationship, and explain? So remember guys, in order for a graph to be proportional it must go through the origin and it must be a straight line. So notice how our graph does go through the origin and it is a straight line, so that means that it is proportional. So we would put yes, and you must write down both requirements. So we will put yes because the graph goes through the origin, and it's a straight line. So if you guys were to only put one of the requirements, like if you guys just put yes because it's a straight line, that is not correct, because I can show you guys a graph that's a straight line that doesn't go through the origin, right? This is not proportional, so you can't put yes because it's a straight line. You also cannot put yes because it goes through the origin, because I can show you a graph that goes through the origin, but it's not a straight line, which means that it's not proportional. Okay, so that's why that you must put both requirements in your sentence to make sure that you get your full credit. All right, moving on to number 19. So cyclists were 3/4 finished with their ride when they reached the 18-kilometer mark. How long was their ride? So what we are doing here is when they were 3/4 finished, they were at the 18-kilometer mark. So we need to figure out how much more do they have left. So what we're doing here is we are going to take 3/4 times, so 3/4 of the 18, to figure out how much more do they have left. So when we take the 3/4 times 18, so I'm going to show my work here. So 3/4 of 18 means I'm multiplying. They had 13.5 kilometers left in their ride. So what we are going to do is we are going to take what they have left, because this would be 1/4 of it, and we are going to add it to our 18-kilometer marks that they've already done, and that will tell us the total length of what they're riding. So 18 plus this 13.5 gives us 31.5 kilometers. All right, and the last one here, number 20. So Jamie and Ryan work at the grocery store. The wages earned for the weekend are shown in the table and graph. What is Jamie's pay per hour and what is Ryan's pay per hour? And who gets paid more per hour, and explain? All right, so when we are trying to figure out how much they make per hour, we are pretty much just finding the slope, or in other words, the unit rate. All right, so remember, when you're finding the unit rate of a table, you can do one of two things. You can find the slope by looking at your change in y's over your change in x's, or the unit rate, which I think is a little bit easier, which is taking your y value and dividing it by your x value. So in this one, again, money is in our numerator because it depends on the time that Jamie works. So my ratios here will be 24/3, 32/4, and 40 over 5. So when I'm finding the unit rates of these, I'm just going to take numerator divided by denominator. And notice how when I take 24 divided by 3, 32 divided by 4, and 40 divided by 5, I get 8 every time. So this means that Jamie makes $8 per 1 hour. Okay, so let's do the same thing with Ryan. So notice how Ryan's graph, there's not any point besides 0, 0 that crosses at intersections. So I'm going to pick one that's kind of close and just approximate it. So notice how what we're doing is we are rising about 2.5 each time, because that would be the number in between 0 and 5, because if I were to take 5 divided by 2, that gives me that 2.5 there, okay? So let's say I pick this point and this point, and I'm going to say it's about right here on that line, okay? So again, when I'm finding the slope of the line, I'm using rise over run. Or if I wanted to find the unit rate, I can just go over 1 hour and then up to see where that line crosses at 1 hour, which is 7.5. Or, like I said, we can just find the slope. So I'm rising to get to my second point. So if I'm going from 0 to 7.5, that means that I rose 7.5. And then when I'm running, I'm going from 0 to 1. So that means that I'm running 1. So that means that my slope is 7.5 per 1 hour. So Jamie makes $8 an hour. Ryan makes $7.50 an hour. So who gets paid more per hour? Well, Jamie does. Because she makes $8 an hour, where Ryan only makes $7.50 an hour. And that's all that you'll have to put, okay? All right, so this is your study guide to your test. So please, please, please make sure that you guys understand everything that's on here, because you will see this stuff on your test. A couple of things that we did won't be on there, but for the most part, this is your guys' test. So if you guys have any questions, please ask your teacher and let us know so that we can help you.